So I'm here to talk about Amazon Web Services and talk about their how their services can be used for what they call a serverless backend, or what I learned they even call it serverless computing, which I kind of think is stupid. But anyway, so here we go. Okay, anyone who's been around as long as I have knows that Amazon started with selling books. So when I went to university, you could buy cheap books from Amazon. They weren't that cheap since you had to pay for the freight to Sweden, but anyway. But they've evolved, and now they sell everything. So in 2003, two guys, they thought that, because they were building all this infrastructure with servers and scaling and whatnot, but what you get when you build all this infrastructure is that you're getting more than you need. Like most of the time, you don't need all the servers. You don't need everything, all the memory, and so they presented an idea that they should start sell their unused compute power to other companies. So in 2004, they launched their first service, which was SQS, which is Simple Queue Service. And eventually, 2 years later, it became AWS, which stands for Amazon Web Services. And by 2007, it was used by more than 180,000 developers. And 3 years later, all of Amazon.com is inside the AWS infrastructure. And in 2012 is the first reInvent. I was trying not to do this, to read from the slides, but I'm sorry, this is the first one. In 2014, I think it's good. They committed to be 100% renewable energy for all the data centers. And in 2016, their reInvent had 30,000 attendance. And that was crazy. So, their infrastructure. So how they built up is that they have what they call regions. And they have regions all over the world. Today, it's 14 regions. It's soon going to be 15 regions. And the next region is in Stockholm. So we're getting our own Swedish region. Each region consists of at least 2 availability zones. And an availability zone is basically a data center. And the data centers, they are in different geographical locations. So they're not susceptible to the same threats from the outside. So if there's an earthquake in one data center, another data center survives and can take over and still keep running. So it's they have a lot of redundancy, and it's very secure. So you can see there now it's 38 availability zones in total. So when you use a region, you then decide different services in what availability zone you'll have them. We'll get into that later a little bit. Then they also have something they call edge locations. And edge locations is basically, it's a data cache. So for some services, you can get a cache that's closer to your end user. And it's typically used for a service they have is CloudFront. So the first, so if you need data and you put it behind a CloudFront, a user's first call for that data will move it to the CloudFront, and then subsequent calls will be much faster. Today we do have edge locations in Sweden, so I guess it's one of them or a couple of them, those that will be becoming their own availability zones and be part of the region. Okay. I wanted to start with access and security, since that's a really hot topic. And the way that Amazon has that at everything, every user that has access to an account, you give them an IAM user, IAM, which is Identity Access Management. And to a user, you then give policies, and you can create groups and roles and whatnot. And so that's their basic handling of, and also when you create a new service, the service also you handle, you give a service a role and a policy. So you can give it. Now I wish I wouldn't have done it this way, because it'll be easier when we get in further. But so one resource that needs to access another resource, then within a policy, you can tell it that this resource can only access that resource. And then it won't be able to access any other resource except that resource. And no one else will be able to access unless they have in their user or in their role. And also what they have is what they call a VPC, a virtual private cloud. And a virtual private cloud is basically, it's your own little part of AWS. So within your VPC, you can set up subnets, and within a subnet, so when you set up a VPC, you set up the IP addresses, like how many IP addresses and in what range, and you have, and it's the So the IP addresses you can choose between is 10.0.0.0 and 172.16.0.0 and 192.860.0.0, which is the normal private IP addresses. So when you set up your VPC, you first decide what IP range you want, and then you can divide those IP ranges into subnets. And the subnets you can either make private or public, which means that a private can only be reached from within the VPC, and a public you would use to access from the outside. So this is really nice to so when you have like for instance, if you have a database, you don't want everyone to have access to that database, then you would typically put it within a private subnet and then access it through the public. So anyone who needs access to it would go through the public and then to the private. So, and you can have different layers, and also the subnets you can put within different availability zones. So you can have several subnets in several availability zones within your region, which is really good security to Okay, so now I wanted to start talking about the different services. I'm going to start with EC2, Elastic Cloud Compute. And what this is basically it's a virtual machine, or it is a virtual machine. And this is more or less their backbone. So what you do when you can provision virtual machines, and then you decide what kind of operating system you want. So they have different, they have their own Linux brand, but they also can set up a virtual machine which runs Ubuntu. And they even have Windows. And when you, but the thing with a virtual, with an EC2 is that once you set it up, they have a free tier. So it doesn't, the first year it doesn't cost you anything, depending on how large. So when you set up an EC2, you decide how much RAM it uses and what type of storage it uses. And those are the things that you're going to need to pay for.
Yeah. Can I have a question now, or you want to wait for
later? Yeah, go ahead.
No, so actually, I tried setting up the EC2 a couple of days ago.
Yeah.
And I noticed like the Ubuntu is 14.04 and not 16.04. And so I guess they wanted to use Amazon Linux. So how is that different from like a normal, regular Linux distribution?
That I cannot answer. Oops. No, that was why I wanted to have this one. To be honest, I don't know. But they do have 16.
No. Well,
is there on CentOS? Did it say CentOS?
CentOS is basically red.
I know, yeah, it's
Yeah.
But I didn't see 16.04.
So we can see what happens. We go into EC2. Then we can go launch an instance. Seriously, they have. It might be depending on what region you were in, because the regions do have different support for different services.
Okay.
All regions don't have all servers, but I think it should have 1604 anywhere where you are.
Okay. But yeah, but I mean, is there Amazon Linux? Is that something they publicly? Okay, in EasyToE.
Yeah.
Not global. Okay.
Yeah. So here you can see, and they have different flavors of Windows as well. And you can see here if it's free tier eligible, which means that you don't have to pay for it until you're hooked. But yeah, I might as well show. So here you can select different types. So between nano up to an really large image. And these are then you can see storage optimized. So it's depending on what you want to use them for. So if you just want to do a basic, then a general purpose.
How much you want to pay?
Yeah, how much you want to pay, how much you need. Oh yeah, and this purchase a spot instance. This is pretty cool as well, because there are different. They have an auction of compute power. So you set a spot price, where you say, I'm willing to pay this price. So if you have a job that doesn't need to run all the time, like you're doing a big computation, like you're looking for alien spacecrafts, and you're just crunching a lot of data, then you can set a spot price, which will then be like, okay, when your price, if the current price for that instance doesn't go over your spot price, then you can get to run. But otherwise, if the price is higher than you want to pay, then it shuts down and you don't get charged. Oh yeah, and here you can see. So here I would choose a VPC, So every time when you create an account with Amazon, they set up a default VPC for you, which basically, but a default VPC, it's all the subnets within them are public, so they can be set up to be reached from the outside. So if you want to set up with a private subnet, then you need to create your own VPC. So here I created one, and with 2 subnets. So this EU West 1A, that's one availability zone, which means one data center, and then 1B is a different data center within the same region. So the way I've set it, and I can't remember now, but I think this one is a private one, which means that if I start this instance, I won't be able to SSH into it from outside my virtual private cloud. Then I need to set up an EC2 in my public, which I then can SSH into, which I then can access the one within the private. And here's also, you can set up IAM roles. And I might as well show you since I talked about it. Anything here? So here are some existing roles. We can create a new role. So this role type with Amazon EC2, that will give instant access to what you need to run an EC2 instance. So when you set up, with the web console, they really help you a lot. So to make the right decisions. Then you can do it a lot more specific for your solution when you know what you're doing. Okay. Oops. I'll go. So I think I covered what I wanted to talk about on EC2s. Okay. And then they have different storage solutions. S3 is basic simple storage service. It's one of their oldest services that they have. And it's just for storing objects. Typically it's pictures, videos, whatever, just anything that's just an object that you need to store somewhere. So it's not a place that you put a database on. It's not a place to have your operating system or stuff like that. It's just for storing files and objects. And things to remember with the S3 is they say that you get unlimited storage. Of course, you pay for what you store. And the more you store, the more you pay. But it also, you have different, like a basic S3, they claim it's built for 99.99% availability. They guarantee 99.9% availability. And then in durability, which means that they say you won't lose any data because they guarantee 99 dot, and then it's, they say it 11 times 9. So 99.999 up to 11 nines. Durability, which means they say you're not losing any data. And you'll basically always be able to access it. So one of the services that runs on S3 is Dropbox. But if you have a lot of stuff lying about, oh yeah, and a single file on S3 can be up to 5 terabytes, which is pretty good. I don't think I have any movies at home in that size. But if you have a lot of stuff stored that you don't access a lot, then they have something that they call Glacier, which is meant for long time storage. It's typically if you have data that you need to store for things you just need to keep, but you never expect that you need to look at again. So typically for compliance reasons, or yeah, if you're that kind of guy, yeah. if you save all your junk mail, that's a place to put it. And Glacier, it's really cheap storage, but the thing is, to access it, it can take a couple of hours. So for the first read, then once. But this is also, they have a different, like if you're ready to pay more, then you can get it faster. But Glacier, it costs about, let's see, oh yeah, to read from Glacier costs about 1 cent per gigabyte. So it's really, really cheap. And the last type of storage, which is Elastic File Service, EFS, it's a block-based storage. And an EFS, you add a storage to your EC2 instances. So this means that you can have several EC2 instances that's reading from the same storage. So if you have a website that you get a lot of traffic from, then you can have several EC2 that serves the website, but they're reading from the same storage.
And only one can write for consistency.
I'm not sure about the consistency on the Elastic File Service. I know on S3, you have what they call eventual, a new write is pretty fast, and the consistency there is fast. But then an overwrite or a delete can take some time. So they have what they call eventual consistency, which means, but you will, on S3s, you won't get broken reads. You'll either get the old object or the new object if you do it before a write has finished. So, oh yeah, and another thing with S3 is that it's they have you must have a global unique name when you name your S3 buckets, because they're the same all over the world. Okay, moving on to databases. So RDS is their service for relational databases, relational database service. And then they have support for MySQL, MariaDB, Postgres, Oracle, and Aurora. And Aurora is Amazon's own relational database. What I'll get into in just a second. I think we're gonna see if we can. Where were we? There we are. It's so much easier to do it from here. See if I have any. Oh. So Aurora is their own, so they're really pushing for it. But here you can select what kind of database you want. And the way it works is that you connect an EC2 instance to your database. But this EC2 instance, you can only access the database. You can't SSH into it. So for MySQL, you'll go through its normal 3306 port. Yeah, you can see it supports data up to 6 terabytes, and how much are it willing to pay in CPUs and memory. And thing with these databases, you can then have different redundancies connected to it. So you can either have them over multiple ACs, which means that you can have a database in different availability zones. So when you're writing, so you'll have one which works as the master, basically, that you're writing to, and then it's automatically copied to another availability zone. And if that availability zone goes down, or if that EC2 goes down for some reason, then it'll automatically fail over to the second one. So you won't be losing any time or any data. You're paying when you're setting it up. When you set it up within the free tier, then it's just one availability zone, one database, and then everything you add on, you're paying. And another way to get redundancy is also you can set up the read replicas. So you can have several read replicas of the same database, and then you can set up, they call it tiers for these read replicas. So if your main database fails, then the read replica will take over as the main database, and so forth. And then I wanted to touch a little bit more on Aurora, which is Amazon's own database, relational database. And it's MySQL compatible, so anything you do in a MySQL database you can do in Aurora. They're building on it, soon will be Postgres as well. So you can, I guess you'll be able to choose between an Aurora MySQL or Aurora Postgres. And they claim it's up to 5 times better performance than a regular MySQL, to a tenth of the cost of basically Oracle. And it scales. So when you create an Aurora database, you get 10 gigabytes of storage, and it'll automatically scale up. So every time you need more storage, it'll add 10 gigabytes. So when you reach the limit, and this is automatic, and it'll scale up to 64 terabytes. You can have 32 CPUs and 244 gigabytes of RAM, but that doesn't auto-scale. Then you need to pause the database, change the EC2 that it's running, and then start it up again. It usually only, it's a minute, takes a couple of minutes, but it's fairly easy, but it's not an automatic. So when you start one up and you put it in an availability zone, it'll have 2 copies in that availability zones. Or actually, it'll put it in more than, it will put it in 3 availability zones. So you'll have at least 6 copies of your database. So it's really redundant. And it's supposed to be able, writes, it's supposed to be able to keep on doing writes, even with the loss of 2 copies. And reads, it can continue to do reads even if it loses 3 copies. So it's really built to be durable and dependable. And then the storage is self-healing. So they're always scanning the disks for errors and replacing them if they need, or self-healing as they call it. And when you have, and then they have two types of replicas. You can either have the MySQL type of replicas or the Aurora replicas. And the Aurora replicas, you can have up to 15 replicas. The MySQL, you can have 5 replicas, which is the same for the other type of MySQL replicas.
Is it built on something? I mean, is it built on MySQL or is it wrote their own stuff?
I think they wrote their own stuff, but they've used the MySQL's specifications. Or
So why would they keep offering MySQL if Aurora is compatible with
well, because MySQL is still cheaper on AWS for a startup. Like the thing is, like a lot of these stuff that they build for most projects don't need it. Like you don't need to have a server in Europe and a server in Asia, and you don't need to switch between the different. So this is built for really big databases where you need this auto scaling. If you're about to handle lots of data, so it's built for like Netflix and.
Aurora is only cheaper when you scale it to multiple.
Yeah, if you compare it to Oracle and what you would be paying for Oracle.
Yeah, I should also point in that Aurora, answering your question, is only specific to one specific version of MySQL.
Yeah.
So you might have SQL code that is not compatible with exactly that version.
Yeah. And then their other database is DynamoDB. And this is a NoSQL database. So but it supports both documents and key value data models. And what they claim, it delivers consistent single-digit millisecond latency at any scale. So you can have a large database as you want, but it should consistently deliver data within 1 millisecond. And this one has push button scaling. So when you set it up, you provision how large it is. And then if you notice like, oh, I'm getting a peak, then you can automatically go into the console and say, okay, I need to be able to read and write this much now. And it'll automatically scale without any downtime. And the DynamoDB, it's always on SSDs, which means it's really fast reads. It's really built for lots of reads. So if you have a need to be able to read a lot, then DynamoDB is really good. It's not the performance of writing is still good. It's not as good as the reads. So if you don't write as much but read a lot, then DynamoDB is a really good database. And it's set up so it's in 3 geographically distinct locations. So it's basically so when you set up your database, you'll have it in 3 different places. And when you do a read, they have what they call 2 different consistency models, which is eventual consistency. And eventual consistency, if you have done a write, then if you can wait 1 second before you start reading, then the write will be done, and you'll get the new data. The other model is strongly consistent. And here, they guarantee that you'll always be getting, they'll wait, before you do the read, they'll wait for the write to finish before they do the read. So it might be it might be slower actually, but you'll always get the correct data. So it's depending on your application, what you need and how it works. Oops. I wasn't going to use that. Sorry. So, lambdas. Lambda is not Java lambdas, it's not Python lambdas. An AWS Lambda is a small stateless program. It's just a snippet of code, basically. And they support Python, Java, JavaScript, and C#. And the way it works is that you create your Lambda and put it in AWS, and then you create triggers. So might as well show it here. So let's see. So here you can select your runtime, and they just in these days they released support for Python 3. I'll do the hello world. Okay, so a trigger will run the Lambda, and these are the triggers that are supported. So let's do it. So let's do an S3. Then you select. Oops, wrong one. What S3 you want to trigger, and what event. So what this means, whenever an object is written to that S3 bucket, this Lambda will run. So in here you can add your code. You can either write it inline or copy paste, or upload a zip file. So if you have a more complex Lambda than just a single file that has a lot of dependencies, then you create a zip file that contains everything you need. And then within the Lambda, you can then write to a database, write to an S3, do whatever you need to do within the the program. So it's really a good solution for building microservices. So when you create your Lambda, let's see. Here we are. Of course, you need to choose a role for it. And here you can set up how much memory you want it to be able to consume. And this is, of course, the more memory, the more it'll cost. And then you also set a timeout, because they won't run longer than the timeout you set. So this is for short programs. They shouldn't be, I believe the maximum timeout is 3 minutes. Or if they, might be 5 now, let's see. It's 5 now, yeah. It used to be 3, but now it's 5. So it won't run more than 5 minutes. So it's not for the long compute stuff that you put in an EC2 in a spot instance. But after this time, it'll it doesn't matter how far it's come. It'll die. It'll get killed. So when you do your application, you can have several lambdas within it that then depend on each other depending on what you want to do. So it's a really neat neat technology.
Where do you go if you want to read the print statement?
Okay, yeah. You go to let's see, where was it there? Let's see if I had a Lambda. So you can go to monitoring. Then you can go into CloudWatch. So in CloudWatch, it creates logs whenever it writes them. So here you can go in and see.
Where does it execute? Does it execute in the VPC?
Here, yeah. Depending on what VPC you set it up to execute within, and what subnet.
You can execute in that subnet.
Yeah. All right, here we are. Okay, and then the final brick that I'm presenting for the serverless solution is the API gateway. And this is a place where you set up an API, or it's a RESTful API. And the easiest way to do this is see, where were we? They have support for Swagger. So within Swagger, you design and build and document your API. And then this API will then be accessible from the outside. I think it's really cool that they decided to support Swagger and not build something themselves. And so what this allows you then to do is that you have your API in the Amazon API gateway. And this, in this example, I placed it within a subnet. And this will then be the public subnet that's accessible from the outside. And it'll be, of course, accessible from like mobile devices or IoT or whatever. And then I put a Lambda that then handles calls from the API, and then it does whatever it needs. If it's reading or writing to an RDS or a DynamoDB or writing.
So I would assume that it's cheaper to do that than leave a VM running.
Yeah. So this will basically, the API gateway you'll be paying for calls to it. The Lambda you pay when they run, and the database you pay when they're written and read from. And the S3 you pay for storage and when they're accessed. So this is, when it's not doing anything, this will virtually be free. Okay, and to manage this, you got a quick view of CloudWatch. The basic thing to do in CloudWatch is you can view the logs, but you can also set up alarms. and it's alarms like if something goes wrong, or if cost exceeds a set limit. So if it starts to get really expensive, then you can have like that it kills the service. And then also I wanted to mention CloudFormation. And CloudFormation is a scripting tool where you set up your... So when you've created your next killer application within the Amazon, within its cloud, then you can have a script where you just define everything with the different lambdas, the roles they use, what VPC they're in, which then allows you to set up the same environment in another region. So you can run your CloudFormation in different regions and have the same, or copies of the same environment in different regions, which allows you to really get up to speed in new places if you're a startup. Oh yeah, and this is a terrible picture I took at reInvent. But these are what they're talking about, what Amazon is talking about when they're talking serverless. So serverless is, of course, a modified truth. Because of course there's a server running somewhere, but the thing is you don't have to care about it. You don't need a big. You don't need to have a big data center. You don't need to buy servers, and you don't need to upgrade them and do all that stuff. Like Amazon does that for you, and they probably do it better than you do, than most organizations do, I guess. Of course, they also do have their mishaps. I don't know how many of you have heard about the S3 problem they had, which was a really, I don't know, they were doing debugging, and they were using a tool, and someone wrote the wrong command, so they brought down more servers than they intended, which made that the service wasn't working, which then, since it was S3, and S3 has a global namespace, it took some time for them to get it up and running again.
So the 99.9999.
That's where the that's where the nines stopped. And then I wanted to, so of course there's pros and cons. The pros that I see it's the availability is fantastic. The scalability is great. You don't need to have a big hardware infrastructure with IT operations or sysadmins.
Do they have an SLA on the Lambda services?
SLA?
On the Lambda services? Like 99.9? Service level agreement. Service level agreement.
Oh, I don't know. I can't answer that. Sorry. But then the cons, of course. Like I'm standing here and talking a lot about cost. And you need really be aware of the dollars, because you can make a fantastic solution, like have 50 lambdas ready to fire up at the same time. But if they all fire up at the same time, it will be incurring costs. Because one thing with lambdas, it's like, they're just lying there. But the first call, like when they boot up, it takes a lot longer than subsequent calls. So if you call the same lambda many times, the subsequent times will be a lot quicker than the first time. But you're still paying for the amount that they're running. So it's a good idea to have lambdas that are kind of hot and ready to go all the time, or most of the time. And then, yes, in Amazon we trust. But it's the same with, I guess, any cloud service. It's also in Google we trust. And it's also like it's with any new development tool or technology. There's no silver bullet. You're just choosing another set of problems. So it might be the problems you want to have. Or maybe you want to have a big data center. It's up to you. And I think that's it.